YouTube channel as soon as we can. So thanks everyone for coming. This is our quarterly webinar with the California Data Collaborative. So the webinar today, we've titled it, What's the Data Really Telling Us? And so we've got some great speakers. We're really excited to have Negin Ashoori and Tom Francis from the Bay Area Water Supply and Conservation Agency, and Russell Perry from Alameda County Water District. So thank you all for joining us. So I wanted to just give you a brief, welcome, a little bit about our speakers, talk a little bit about who the California Data Collaborative is. We'll have our three presentations, and then we'll have a few announcements at the end. So our speakers have agreed to come and talk to us today. We're here at Alameda County Water District. Thank you so much for hosting us. The reason that we chose to have these particular speakers come and talk is that they're doing a lot of interesting work with their data. And so when we reached out and said, hey, can you share some of this? They were like, absolutely. So we're really thankful that you're here and that our members and folks that are interested in water industry and data that comes along with that, that you're able to share your story and hopefully hope others, get some great insights and maybe how they can use their data. So the California Data Collaborative, we are a nonprofit. We are essentially governed by our members who are water suppliers in California, and we help them to use their data for resilient water management. We have 26 members. We range from very small urban water suppliers to very large wholesalers from across the state. And we have essentially 4 areas that we work in. So collaboration is key. It's actually in our name. So we do a lot of that. Our members are very active. We have different committees. All of our members participate in our steering committee. And we also work outside of our membership. So we work with academics, we work with other nonprofits, and we also work with vendors who are offering software solutions as well. We do have some of our own software that's both available as part of a membership subscription, but we also have free resources and tools. We've just launched a new product called Wavelet. This is really to help water agencies look at their demand, their consumption data, and be able to gain a whole bunch of insights into how their customers are using water. And there's a free version of that thanks to a very generous grant that we got from USBR. So if you're interested in that, please take a look at our website. There's some information later on if you want to get access to that. We also do some consulting. It's a very small part of what we do, and we do some consulting work to help, other agencies that are really looking to dig into their data and find some new understanding. We participate in different work groups and advisor groups, and we do participate not only in research, but we're trying to expand that and really become a hub for research where we're connecting academics and suppliers on relevant projects to help the whole water industry at large. And then like today, we do a lot of education and outreach. We have our quarterly workshops and webinars. We also have an annual data summit, and we have an online community. So if you haven't checked that out yet, please do. This is where we post free resources, and you can see all the latest and greatest that is happening. So talked about our speakers, and I'm going to hand it over to Russell, who's going to be our first presenter, and he's going to talk about all of the cool stuff they're doing with their AMI and what they're looking forward to doing in the future. So thanks.
Awesome. Thank you, Kim. Yeah, so my name is Russ Perry. I'm a water resources systems analyst here at Alameda County Water District. I prefer the shorter title data nerd. I think a lot of us can probably relate to. And the topic is really going to be focusing on what's happening now that we, as of this month, have finished installing all of our AMI meters and gotten our infrastructure into place. Before I dive into that, I'll give you a little bit of background about Alameda County Water District, give you a sense of the scale of operations here. So we serve 3 cities in the Southeast Bay. We don't cover the whole Alameda County, just these 3. We were founded in 1914 to manage the groundwater aquifer here and our water rights out in the hills east of Fremont. And so we have a large population, around 350,000 people, 87,000 accounts or connections, and we have a pretty diverse water portfolio to support all of that. About 40% of it is our local water shed runoff and management to the aquifer. Looks like we lost the gray bullet point here. That's SFPUC, San Francisco Public Utilities Commission. That forms about 20%. And then the last 40% comes from the state water project. And as you might imagine, that can change quite a bit year to year, especially in drought years. The whole wheel might change. But in general, it's a complex but luckily diverse water portfolio that we manage. Is that a hand raise? So the question you might ask to start is why AMI? I've chosen to highlight just a couple of the business cases that we'll be talking about today, but there are many more. So we'll be focusing on the leak detection and notification system, and then two analyses that kind of come together. One is about the increased customer awareness that comes from having access to your flow data at your fingertips as a customer. And the other is about the revenue recovery that you expect from installing higher tech meters, replacing the typical positive displacement meters, such as in our district. Those two are, I'll demonstrate, somewhat at odds with each other for measuring. So the infrastructure we went with for AMI was Badger's E-Series ultrasonic meters. They're highly accurate, down to a 20th of a gallon per minute, and they deliver the data in 15-minute increments. So there's a high time fidelity as well as the flow fidelity. They receive the data 4 times a day, which then gets fed into our customer portal that is created by Smart Energy Water. It has the payment system right next to the consumption, so consumers are really have the data at their fingertips and they're encouraged to go explore it. The customer view can get down to that same 15-minute water usage. So if someone really wants to nerd out on their data, the options available to them. And then that is also where our leak notifications are delivered from, as well as high use alerts. We won't be talking about high use alerts so much today. We're going to be mainly focusing on the leak alerts, but it's a similar sort of system. And the image you see here is an example of what a customer might see of their daily usage delivered by AMI. You can see how it color codes the bars to tell them when they're having a below average day. So maybe they can make some inferences about how their behavior led to that, and they can really manage their water bill from a behavior standpoint. So we've entered the new era of ACWD. ACWD after deployment. The meters are installed. What's next? And as a member of the CaDC, I think it's probably one of your favorite things, analysis. So there's going to be 3 analyses that we're really focusing on as our next steps. And I want to emphasize these are next steps, not current things that we have done, but things that we intend to do and are building the capabilities to do. First of which is really optimizing those leak notifications to make them as useful as possible to our customers without really flooding them with notifications. We also want to take a stab at developing the prevented leak water savings, which is a kind of a nebulous question. We know that it's saving water, but how much? And how does one go about calculating that? The aforementioned customer behavior change that comes with more awareness of the water usage. And we expect to see reduced usage, but we'll know when we measure it. And the last one is the reduction of meter under registration, that revenue recovery. It's closing the gap between the production and consumption, making sure we're really accounting for every drop that we can. So to give a quick overview of how a leak alert works, you may already be familiar with this, but in case you're not, they tend to work with very simple algorithms. Depending on your vendor, they may vary. In our case, it is 1 flow threshold that you set and 2 time thresholds. So I have this example here of measuring continuous flow that is greater than 7.5 gallons per minute or 1 cubic foot for 23 more hours out of the last 24. And so in these 2 figures on the top, you can see an example of what would be considered a leak in a somewhat contrived example where you're seeing the average flow in a 2-hour period. But you can imagine this being a 24-hour period looking at the more granular data. Excuse me. And then an example of what's not a leak. Now in this what's not a leak example, you can also see, if you look really closely, that at 8 p.m. there is still a little bit of flow. So you might say, well, isn't that maybe a leak too? And so it begs the question, how do we know it's a leak? We don't. So we do what we can with what we have, which is to recognize that we are finding continuous flow. And really the thing to optimize with an algorithm that's simple like this is to optimize for messaging, making sure that the messages about leaks are identifying leaks that are noteworthy enough and that aren't going to spam your customers. So you can kind of imagine a spectrum of options for how you set it up. On one end, you have the system that's just not sensitive enough. Customers aren't receiving any information. On the other hand, they're receiving far too much information. They're learning to ignore your leak notifications. And what we're shooting for is right in the middle, good enough. Not perfect, but good enough, because there's so many diverse uses of water and customers using that water. You're never going to get a perfect solution, but you're trying to optimize for good enough. So the takeaway there is try not to spam your customers while still making the leak notifications useful. We've developed and are developing a few tools to help with that. The first is, and this is a feature offered by SEW through their customer portal, the ability to segment your customers based on categorical variables. I have some listed examples here of like lot size, the amount of people in the home, whether or not they have a landscape, whether or not they have a pool. We collect that data using a survey in the portal, and we use various avenues to direct customers to it. You will notice there's a little gear icon here that is going to be used throughout the rest of the slides to indicate that something is still in development. So we're still working to get these categorical variables working well. And you might say lot size is more of a continuous thing that could be any number on any number of square feet, but we're trying to bin it into, say, 1,000 square foot bins of lot sizes. That works together with two other tools. This one is also in development, our leak notification log. This includes a history of the notifications that were sent, both the statistics of the leak that was identified, what was the flow, what was the duration that was measured, and also what thresholds were used to find that measurement. Because we want to see how the sensitivity is working, and that will feed back into how we set up the leak notifications through those segments. Then the last missing part of this is making sure the customers have a way to communicate to us about it. And so we've also created a customer survey that we direct them to following a leak notification, asking, hey, did you actually find a leak? Where was it? Was there anything else you'd like to tell us? It works very well with the leak notification log, and this one is implemented. It's no gear icon. But the intention is for it to work alongside the leak notification log together to optimize the segmenting and the thresholds for those segments. The segments is where we set the leak thresholds. So here's it in a more pictographic diagram. You see there's kind of two loops that work together to really feed back into optimizing the segmenting. And the data collection is essential to make sure that you're doing it in the most effective way possible. Now, leaks are great and one of the biggest draws of AMI, but we also have many other interests. And I'm going to dive into the second one that was listed from the start, which is about the customer water usage awareness. So we opted when we rolled out the AMI to roll all of our e-bill paying customers into the SEW notification system. So we went with an opt-out strategy. This resulted in about 80% enrollment in our notification system. And again, it puts the water usage right next to bill pay. So the customers are receiving notifications, they're being drawn into the portal, and the data is at their fingertips. I have a couple of displays here of what a customer might see. On the left is, or sorry, on the right is your left is the usage, just like in that earlier slide where it shows kind of the average usage and below average usage, so a customer can gain feedback about how they're using the water. And then if they're more competitive spirited, this slide on the right, this image on the right shows their usage compared to similar customers. And it's clever because, well, my data is way higher than other customers. What's that about? Well, maybe it's not accurate to you because you didn't fill out the survey. So it also routes customers back to the survey so we can make sure they're getting the best information for them and the best information for us. Now, this expectation of reduced usage is somewhat at odds with another benefit we expect from AMI, which is reduced under-registration. So reduced under-registration is about replacing old meters that can't detect, say, low flows. So we expect on an AMI install for their demand to go up. What that might look like is on the conservation side, you have the AMI installed at some point in time, and then sometime later, it results in a reduction in usage on average. Whereas the moment the meter is installed, you should expect an increase in consumption, not because there's more water being used, but because you're now measuring it all. So these two are at odds with each other. So it creates for a complex analysis to really separate the two. Fortunately, they are temporally separated. And I apologize, this slide is full of text, but it's because we're trying to describe a complex problem. So on one side, you have immediate revenue recovery as the meters are replaced. And on the other end, you have the conservation that takes longer. And you have a lot of limitations on how to measure this because necessarily up until the AMI meter is installed, you're in a bi-monthly system. So your data before the AMI meter install has to come from a bi-monthly data set. And that somewhat necessitates that the data afterwards also needs to come from a bi-monthly data set. So it's not really an AMI analysis so much as it is a more accurate meter analysis. How much is that more accurate meter gaining you in regards to the revenue recovery, the reduced under registration? On the conservation side, you should be able to measure that using just the AMI data, but you need to be able to separate the two. So we have a set of available data to help us with that. We know when the meters were installed. We have the time series of the consumption data. We have exogenous variables, but we want to avoid using them if we can by being kind of naive and lazy about it and pairing them with customers that didn't have AMI installed that are similar over the same time period. And hopefully that will help us isolate that under registration issue and over time also observe the conservation thing. But the other challenge is we don't know what effect size to really expect here. Typically, if you're doing an AWWA water loss audit, the default assumption for under registration is about 2%. So being able to suss that out among COVID, drought, and all the crazy weather that we've had is going to be quite difficult. So we don't know what kind of effect size we're going to be looking for and how statistically clever we're going to need to be to find it. So this is one slide where I'd really welcome any feedback, or even better, people have done it before and can send us their analysis, because it's going to be quite challenging, and just our first attempts at it have been quite difficult. And also, you can see that gear icon top left, very much work in progress. So to summarize these two kind of sets of analyses that are immediate goals following this installation, we have the leak thresholds to minimize spam, but optimize for finding real leaks and helping the customers. It's challenged by our kind of one-way communication. We've tried to close that feedback loop with a survey, but getting customers to fill it out is a whole challenge in itself. And then additionally, we want to be able to isolate and measure the benefits both from the customer awareness increase, how that's going to lower their usage, and how that balances against the reduced under registration, where we're now gathering all the flow that's actually occurring. And that has its own set of challenges. But it begs the question, what else could we do with AMI? Surely this isn't it, although these are some of the major business cases, and that's a question we intend to explore very thoroughly. To give a sense of the scale of change that AMI brings to our district in particular, we have 87,000 meters. They record every 15 minutes, so that's 96 records per meter per day. Scaling that out, that's over 8 million records per day that are being delivered. If you take that out by a year, we're over 3 billion records of water consumption per year. And that's not even accounting for that there might be multiple registers on those meters, and so there's even more records. So to kind of put that in context, in the 12 years that we've had our previous bi-monthly billing system, we would expect for the same number of meters to generate around 6 million records, which is less than AMI generates in a single day. So it is a seismic shift in how we can work with and what we might be able to do with this data. And the question is, how can we tap into that potential? So with that huge potential, it's delivered also nearly real time instead of 2 months later. It is more precise than those positive displacement meters because it is using the ultrasonic technology, and it's at a finer time scale, about a 1 to 6,000 change in time fidelity. So it should be able to find things that just weren't present in bi-monthly data as well. With that huge potential, though, comes some huge challenges. One, when you're working with cloud systems, APIs, which is an application programming interface, it's analogous to a UI, user interface, but it's for computers. When you're working with those sorts of systems, it is a lot trickier to move data around. It's not a copy and paste into Excel kind of scenario. And the data is much harder to clean. With such a volume, you need an algorithmic way to clean your data. You can't be going and looking at individual records to find problems. Luckily for us, our meter vendor, Badger, does a lot of the cleaning, but depending on your meter vendor, that might not be your situation. And then the last part is to that note of putting it in Excel, it's very hard to analyze. You can't store 3 billion records in an Excel sheet. Well, there's some techniques, but they're not good. There's better ways to do it, but they're a lot more difficult. And you need computation power available to you to do so. But should you be able to handle that huge challenge, the potential is enormous. And these are just some of the ideas of what we might be able to do with it. CII benchmarking, which is necessary for the urban water use objectives, is one of our ideas. Irrigation detection. Now, some districts have been able to do this with hourly data, depending on how they curtail irrigation. Some cities will say you can only water Tuesdays and Thursdays, so it's pretty easy to measure a spike in water usage outside of Tuesdays and Thursdays. The way we've opted to do it is you can only water X number of days per week during a drought, and that is a little bit more challenging to find because you really need to look for irrigation specifically, not just peaks on off days. There's a lot of other ideas around improving water loss analysis, specifically being able to align your consumption and production to within a day or even maybe finer. There's a lot of ideas around virtual DMAs, which is a district metered area. So you can measure the amount of water going into a section of your distribution system and the amount of water leaving it via customer meters. And the difference will show you whether or not you might have mains leaks or some other problems within that system, depending on your data quality. And then there's all sorts of other ideas. A kind of far-fetched one is doing intervention analysis, looking at point-in-time changes due to messaging, either from the local district or from the state, droughts. Also maybe definitely looking into conservation measures. People installed a toilet. How much water are they saving now? People installed 2 toilets. We should be able to suss out those kinds of differences. So the sky is really the limit on this. It's just about being able to get it all into a cohesive system. So the solution we've decided to go with is very much like the CaDCs. We've decided to go with a Snowflake database. Snowflake, for those unaware, is really a system that sits on top of a lot of these cloud database providers, such as Amazon, Google Cloud, Azure. It abstracts a lot of the complications of managing the scaling of those systems. If you know anything about distributed cloud systems, scaling can really run up your bill fast if you don't know how to manage it. And Snowflake takes care of a lot of that for us, so we can put triggers in place that stop it. Also notice the gear icon, it says in development. But once in place, it will provide on-demand access to this data. We can query it just like a SQL database. So at any time, we can run an ad hoc analysis on the data. The other benefits of Snowflake is that they have a built-in system for creating dashboards and algorithms via Streamlit, which is a Python library that they purchased and now maintain. And it can also integrate with systems you might already have, such as Power BI or Tableau. Whatever system you might have, they should have a way to integrate with it. There are some challenges to that. It's definitely there's challenges to any big data project. One is that it's just a big learning curve due to those aforementioned needs to really think about how to crunch 3 billion records. And getting the data into the database is a whole technological challenge in and of itself. Moving that volume of data around is quite difficult. Using the data has a very different approach than working with Excel sheets or SQL databases even, because you need to, say you have come up with an algorithm you'd like to try, you can't just execute it on your whole set of data. You need to segment it out, really constrain your experiments so that, again, they don't spin up all your compute. And it all boils down to that point number 4 there, managing your spend. That's one of the biggest challenges, is just understanding how an algorithm might scale out. If it's a quadratic situation, if you double the amount of data you're working on, you'll quadruple the amount of computation you need to do, for example. So you really need to be thinking algorithmically when you're working with data at this scale, and it's definitely a shift in mentality. So this is where our current forefront is building this out. As of last week, we were able to get a full day's worth of data into it in a very short amount of time, which is an accomplishment of itself. Now we need to schedule it and things of that sort. Also, it's worth mentioning error handling is quite different in these systems than it is in, say, Python alone. You need to set up what are called listeners to listen for when problems arise and log those and then go look into them afterwards. It's a very different dynamic, is the thing to really emphasize. So with this in the forefront of mind, I'd like to put something else around top of it. I'd be remiss not to use this soapbox to talk a little bit about how with our great statistical power comes a great privacy responsibility. This is what Ben would say if Spider-Man were a data analyst. It's really essential, especially with data like this, where it's customer information, to consider not only what you can do with it, but why you're doing it and what kind of risks or harms could come from developing these algorithms. Because this water usage is coming, from the home, you can actually tell if someone is at work or not, potentially, or if they're on vacation or not. So really thinking through security and privacy at the front of the project and at the front of every data analysis project to do with it is incredibly important, especially with all the new AI tools that are coming out. It's becoming more and more accessible to work with large amounts of data. And so it's just important to keep in mind at all times that this data is sensitive. And you really want to include that security and privacy from the start, because it's much more difficult to add it in later to a project. or even worse, a system. So my soapbox done. That leads to kind of the closeout here. I have a collage of what we touched on throughout the topic here. If there's any questions.
We have a question.
Audience, so.
We're on the ceiling.
Okay,
So you don't need.
okay. So John, if you, let me see if I can unmute you. Yeah. So John, you should be able to unmute and ask your question.
Okay, I was just curious how long you've had smart energy water integrated. So was that kind of all set and your customers were used to that, or were you implementing it at the same time that you were in the last year or 2 years while you're finishing out your AMI? So that's still a work in progress as well.
Yeah, the SEW customer portal is live and it was part of the AMI product. It came on with the AMI meters as part of one full gigantic RFP. So yeah, it's new to us and it's new to the customers and it's new with AMI.
Okay, so you kind of need to sort through both the AMI and the smart energy water system to,
Yeah.
yeah. Okay.
And Badger offers a lot of the same features around leak detection and high use alerts and things like that too. So it was a decision of which one would serve us better. In our case, we went with the one that is going to be more directly available to the customer. But whatever your business case, you might come to a different solution. Definitely does make things more complicated to have multiple vendors involved with the data. This Snowflake thing is a kind of a third and separate thing from SEW. It's not intended to integrate with the SEW side, but it is intended to integrate with Badger to receive all that meter data.
Yeah, we've got Badger and Beacon too, and not super impressed. Thank you.
Yeah, absolutely.
Yeah, so part of the benefit of AMI was the revenue recovery. So you showed that graph, which is conveniently here on the screen. It seems like AMI is both more precise and more accurate, but is it a foregone conclusion that it always captures more? Like, does traditional metering always underestimate volume?
If they're old enough, yes. There's a few studies that show that as they age, they lose the low flow in particular. I believe the minimum flow for AWWA testing is around, I want to say a gallon per minute or something like that. I forget what the exact thing is, but once you get below that, where you're doing like trickle flows and things, they all disappear with older meters. And so it's a foregone conclusion that it will be a recovery. I don't know what circumstances would bring about a meter overestimating water usage, but I'm sure it's happened too. I think on the whole, though, you would expect recovery. Yeah. Yeah, Tom.
Yeah, I was fortunate enough earlier this year to go on a tour of Denmark. It was sponsored by the Danish government, and several others from California and Texas went. Their big push is on water loss, and it's heavily tied to AMI. And the meters they've installed are a different manufacturer than the ones that you're using, but they also have the ability to kind of listen upstream and hear whether there's leaks or water loss occurring in the distribution systems. And I'm just wondering if Badger or any of the meters you were looking at tried to sell you on their meters because of these extra advantages, so to speak.
I'll be honest, I'm not entirely aware if Badger has that particular feature. They did try to sell us on having pressure monitoring as a part of these meters, which is an interesting idea, especially for that kind of leak management. Pressure is a big contributor for how much water you lose through a given traffic pipe. But I don't recall them talking about anything like that, where it's kind of listening acoustically for leaks. We do have a separate pilot project going on with our distribution maintenance crew who are putting meters that do exactly that, kind of echoing detection through a mains pipe for leaks. Yeah, it really depends on also the material of the pipes and things like that. So it's very infrastructure specific from my understanding, which is well.
Yeah, pressure management was an issue there. What they were using their, AMI data or they also have that, what is it, DMRs or DRMs? I always get that mixed up.
Oh, yeah.
District meter. Anyway,
DMA.
yeah, they're using it to also help control the pressure that they're delivering customers. They've found that if, for example, they identify a leak or perhaps there's leaks within one of those measured areas, they'll adjust the water pressure to those areas so that they minimize the amount of loss of water. So anyway, interesting.
And that's something that the state is talking about a lot right now, is about pressure management for leak management. Where it comes to with our district in particular, it's just not the top priority for our pressure management. We have hills and things that we need to manage for inside. But for some districts, that can be a real good way to do it instead of replacing a whole bunch of pipes. At least as a band.
Russell, we have a couple of questions.
Sure.
So the first one is, what's the timeline to get Snowflake full implementation?
Good question. I'm hoping within the next month to have data really in there, but as you saw, full implementation is really, we don't have a specific stopping point, right? So we're going to keep developing and developing, but we're going to be having data delivery regularly in the next couple of weeks. And then we have to backfill all the historic data that was collected during the build out, which is filling the records and is a separate process to backfill all the data into the database. Once we're there, then we really begin developing the algorithms. We're going to be starting with irrigation detection and with what you could call kind of leak detection prototyping. So rather than changing the leak threshold and seeing what customers respond to, you could hypothetically run an analysis and see how many notifications that would have sent, and you can use that to determine the threshold. So that's the two kind of analytics we're going to start with to get more comfortable with all that compute complexity with the system. But we don't really have a point where we're going to be like, it's done. I think we'll be ready to report on it within hoping 2 months, but we'll see. Everything in these projects especially go a little slower than you'd expect.
The next question is, did you choose Snowflake through an RFP process?
No, we actually did multiple RFPs, but we did an RFP to have someone develop it for us, and Snowflake kept popping up as the technology of choice for other people to do it for us. But due to costs, we ended up not going, well, costs and some other considerations, we ended up not going with any of those vendors. But the standout of Snowflake and looking into it for its ease of use and how it removes kind of the middleman that you need to build out your AWS and Azure or whatever base platform that you would go with. It just made a lot of sense from a cost perspective. So this pilot program we put very little money into to launch. And again, it is a pilot. It is a proof of concept that it's worth the value we're going to be paying for it. Should have started with that. Yes, Snowflake is a pilot project. It is not necessarily a long-term commitment.
Next question, are you open to using better tech which can handle time series data faster and in a more scalable way?
Open to it, certainly. But the main thing we're trying to balance with that is flexibility, being able to do as much as we want when we want to. What we saw with a lot of off-the-shelf solutions is they weren't quite what we were looking for, or they were much bigger than we were looking for. And so this allows us the kind of scrappy approach where we can build out what we know we need and see how it works for us. But certainly open to it if anyone has any great ideas.
I think the last question is for the CaDC. So the question is, do you have direct access to meter data, and will the meter data be sending information to the wavelet server? So for the software system that I was talking about in my intro, called Wavelet, there's a free version to any urban California water supplier. And it does require you to manually upload your consumption data. So whether you do that on a bi-monthly basis or a monthly basis, that's up to you. We have some guidelines on how you upload that data at the different fields that are required. So once it's in the system, you would be able to see all of the demand for each of your customers that were in that upload. And then it has different dashboards and visualizations. There are ways for you to generate a list of like high efficiency customers or inefficient customers, or you can, sort in lots of different ways over time by different customer types. So it's got a lot of flexibility. What we're working on now, we did just get awarded a couple weeks ago another USVR grant to enhance Wavelet, where we will actually be able to combine Wavelet, which is the consumption data, with our AMI software. And so once we have that, we'll combine both of those into Wavelet. So we'll have both consumption and that, your AMI data, if that's something that would be under our subscription service fee at this point. So hopefully that answered your question. I think we have a few more. We have one in the room. We'll take,
Yeah, thank you so much, Russ. That was an incredibly insightful presentation.
Thank you.
Without the extra layer of like adding a third party like Snowflake, what are vendors that generate that much data expecting agencies to do with it? Like just save it for like 1 year and then let it go? Or what is the expectation if we weren't to take it to the next level?
I can't speak too much on their behalf. Just what I've observed is the intention is generally to go into kind of off-the-shelf analytics, such as leak detection, high use, or some vendors offer fancier things as well. As far as the storage side, that is one of the solutions that Snowflake provides, is we can just keep the data there as long as we want it, and with whatever retention policy we see for it. With the agreement we have with Badger, we've agreed to a 5-year retention. They've told us that they've never had to drop customer data. At this point, storage is not the expensive part of cloud resources. It's more the compute. But with your own system, you can keep it longer, and that's something you have to work out with whatever your vendor is.
From what I've seen, like, it really varies across the board, like different vendors. Like some of them are kind of, a lot of them kind of just are sort of either just stay in their little silo, like the systems that they're offered, or you're sort of on your own. Some of them don't make it really easy to do the kind of stuff that Russ is doing, pull the data out, work with it on your own. It's really sort of a gap in the market right now.
And it's worth plugging. It's a gap that the CaDC can fill. Their AMI tier, as far as just having the data at your fingertips and really having it under your control. They build out this very infrastructure. So if you don't have the staff on hand to do it, it's a good approach.
So next question, are you open to using Gen AI based solutions to help out your customers?
Yes. When we're currently working on our district AI policy, so I can't speak to what the district's position is, but the general way we talk about it is we can't have black box solutions. We need to understand, for example, if you're having an AI leak detection, or let's say AI irrigation detection, you've got this great AI that can detect when irrigation is happening in a drought, it's not supposed to be happening. And so now you can go after customers who are using more than they should. If it's a black box, you can't really explain how it comes to that conclusion, and that explainability, reliability for us, you're very avoidant to that. So it really needs to be transparent as much as possible. But there's places where AI can fit in, where it is a black box, and it doesn't really matter, where there's not so much consequences. Mainly, I would think around communication, or things like leak notification type communication, where you're sending them a notice to be like, hey, there might be something, but you're not going after them. So it's a delicate thing. So far for me, I only really used Gen AI to help me code, not so much to do anything customer connecting.
So that relates to one of the questions here is, what kind of staff do you use to operate or use Snowflake? Is it easy enough for you to use for water planners, conservation staff, or is it really for IT?
You need a data person to figure it out. It's not an off-the-shelf thing. For example, to get, I'm going to talk data a little bit, so bear with me. But 8 million records a day are generated by Badger, who delivers it via an API, that application programming interface. Every API is different. The way this API works is it delivers it in small batches. And so you need to request the data based on some filters. It'll send you a batch, and at the end of the batch, there'll be a little tag to collect the next batch of the same request. So it doesn't send the whole lot of data at once. And the implementation of that means that you need to create a complex series of queries to pull all the data down and deliver it to your system, especially in a timely manner. And that's just not something someone who's not a programmer is going to be able to just dive into. They might be able to figure it out over time, but it's really not an off-the-shelf solution. It's a built solution requiring some speciality to build, but it's a lot less than it would take to understand all the infrastructure, such as scaling up an AWS Redshift database and building a connector to put it in. It's much easier than that. So if you have someone who's data savvy and is really familiar with APIs and can think about parallel computing to an extent, they could probably crack it. But I wouldn't put it on, say, like a water supervisor or someone who's trying to do command planning. It's just not going to be in their wheelhouse.
We have one last question we'll take before we hand it over to Tom, but do you have any data on the AMI meter replacement impact on water loss?
Not yet, but this is going to be the first year where we run a water loss audit where most of our meters were AMI in 2023. So we do expect to see a difference in our audit this year. And then, as mentioned in the kind of upcoming plans, is that daily alignment of production and consumption should be very insightful for systems. And if we can dive down to that district metered area level, and there's a lot of opportunities, and yet it's very much intended to do, but we haven't seen anything yet. This will be the kickoff of that.
Great, thank you so much, Russell.
That's the one.
Great, so now we're gonna invite Tom Francis up. Ready to go, so you can just-
Thank you. I have to admit, I'm not necessarily a data nerd by any means. I'm glad there's people like Russ around that are, though. That's for sure. So I'm the Water Resources Manager for the Bay Area Water Supply and Conservation Agency. I'm happy to speak to you today. There's actually two speakers. When I'm done, Negin Ashoori will speak, but I'm going to talk about what we're doing relative to a drought report. We're preparing one. We have one that we prepared for the 2014 through 17 drought. And as you folks know, we just finished our most recent drought in, we call it 2023, but actually the rains came in December 2022. But before I jump into that work, I want to mention a little bit about who BOSCA is. I know most of you in the Bay Area are familiar with BOSCA, but if those of you viewing this through the web aren't, BOSCA is an agency that was created to represent 26 separate water agencies. Alameda County Water District is one of them, but there's many more. What they have in common is that they all purchase their water from the San Francisco Public Utilities Commission. SFPUC has a water supply that's generated from Hetch Hetchy Reservoir and the Tuolumne system that's up in the northern part of the Yosemite Valley. And they deliver water all the way to the Bay Area. 1.8 million residents rely on the San Francisco Regional Water System for either all of their water supply or parts of their water supply. ACWD, the agency that I'm speaking from today, only 20% of their water comes from the Hetch Hetchy system. There's other BOSCA member agencies, such as Redwood City, for example, or Foster City over on the peninsula, that rely on the San Francisco system for 100% of their supply. BOSCA was created as an agency, special district, back in 2002. But prior to that, we were a JPA, so our history dates back about 40 years. I listed here on this slide, and for those of you that are watching this on screen, I could read out all of our agencies, but most of them are cities, although there are about 4 or 5 special districts akin to ACWD. We have a couple of unique ones, like Stanford University is actually a BOSCA member agency. They have about 700 homes along with just their standard university facilities. So they're akin to a city in among themselves, but quite different. Here on the Alameda side of the bay, we have 2 agencies. In the Santa Clara County region, we have 8 member agencies. And I'd say most of the water agencies in San Mateo County are members of BOSCA. Not all of them, but most of them. So you add them all together, it equals about 26. Cal Water, which is a for-profit company, provides water to a couple of those agencies that are in San Mateo County. Now I'm going to talk a little bit about our drought report, but before I get into that, I suspect most of you, even if you're not in the water conservation staff of your agencies, have seen these graphics before. And from my perspective, managing the water resources of our agency as well as the conservation efforts, I'm kind of glad I don't have to open a paper or come to a meeting like this and look at one of these maps of California. I mean, we're all fortunate right now that we're not in a drought. Our lives, if we're on the water conservation staff, are a lot easier when we're not under pressure to prepare new flyers to send to our residents or to try to figure out how we're going to squeeze out more conservation savings. But granted, this graphic of California, I have a feeling whether it's going to be next year or the year after that, we're going to see these maps because California is drought prone. One could argue that because of climate change, we're going to see these maps maybe once every other year. You know, I hope not, but that's where we're at. But the 21 through 23 drought, you can kind of see how the intensity of the drought got worse and worse as we entered into calendar year 2022. Thankfully, in the winter months of 2022, we started to get some good rains, even though the drought didn't officially end until essentially July of 2023, when the governor kind of ended the mandate, so to speak. We really did have some water supply challenges during that period. So agencies like BOSCA did a lot of things during that recent drought. We prepared flyers that we made available to our member agencies, just customer flyers that talked about common sense water saving measures. I suspect for those of you in the room, whether you're a consultant or work for an agency, are familiar with these types of documents that you generate for the public. Gosh knows, depending on the governor, they'll take different actions. If you remember in the mid 2010s, Jerry Brown took a different type of action to encourage conservation than our current governor, Newsom, did. But regardless, executive orders were issued most recently during our drought by Governor Newsom. And we as agencies also try to get the message out beyond just the flyers. I have that photo off to the side on that slide of one of the billboards that we used to get the message out. I'll have to say a flyer's pretty cheap. We spent about $70,000 to $80,000 on billboards just in that most recent drought alone. That ran basically 1 week of a message across 11 billboards in the Bay Area. So depending on what you as an agency do, you can spend a lot of money. I'll just say it, a lot of money trying to encourage water conservation or water savings during a drought. So let's think about that. So we've went through droughts before. You know, I'm here with the Data Collaborative today. What did I learn from what happened during that recent drought? I'm one of the older folks around this room compared to my counterparts. I might forget over time. Some of the younger ones, you might forget, okay, what exactly did I have to do in my day-to-day work as an agency staff person? What did I learn? What did I measure? What did I record? Go back to 2014 through 17. What did we do at the agency? You know, what actions were taken by our governing body? You know, what type of drought measures were put in place? At BOSCA, we recognized in 2014 at the end, or excuse me, in 2017 at the end of that drought, that we really needed to make a record of what occurred. And, you know, I'd encourage you, if you're working for an agency, to think about making some similar record of what happened at your agency during the drought, because it will come in handy the next time we go through a 2-3 year drought, just to have that information at hand. So we had a pretty successful report that we put together, and it mostly just talked about the measures that were put in place when Governor Brown took different actions, and locally what our agency actions were. We wanted to do the same thing this time around, but we wanted to take it a few steps further. And so that's what I'm going to talk about today. So we have some work tasks that we developed for this effort. Some of the tasks, if you see, we wanted to do the same thing. We wanted to look at what documents were generated, what records do we have, and review those records that were collected during the most recent drought. BOSCA has 26 agencies, so there's a lot of records that ACWD produced, but there's a lot of records that our member agencies have as well. We also wanted to look at the urban water management plans that our agencies put together, because that has a lot of information in it in terms of what actions they were going to take depending on what drought stage was reached. There was other stakeholder engagement efforts that took place during the drought. We wanted to put that information in this drought report that we're putting together. There's other recommended actions that we put in that 2014 through 17 report. We had met with our agencies and learned what they did, and we made some recommendations as to what they should do next time we had a drought. We wanted to see, did they actually use those recommendations during this most recent drought, or did they forget them? And if they used them, which ones were proven to be more, implementable, so to speak. Last but not least, this is the big part of this effort that I'm going to talk about today, and it's only just getting started. But we want to take a look at, as part of this current report that we're preparing, how effective different drought measures were that were implemented during this past drought. And by effectiveness, we'll look at things like water savings, maybe even things like the cost of each measure, whether or not a certain measure was cost effective. And BOSCA has some agencies that are pretty big, like ACWD, and some agencies that are extremely small. Give you an example, Parisum Hills Water District is a small water district on our peninsula side of the bay. We also have some agencies that are fairly wealthy in terms of the residents. One of our agencies represents Atherton over in San Mateo, Santa Clara region, and some that are fairly poor in terms of their residents. East Palo Alto is one such member agency. So we'll look at demographics as part of doing this analysis about effectiveness. So this is just the schedule for our study. I know when I was approached by the data collaborative, I mentioned a few things that BOSCA is doing, and hopefully this is of interest to you folks in the room and you folks online. We're really just in the midst of it. I'd say it's we're in the middle of the study right now. So some of the slides I'm going to share are sort of the data record slides, some of our early analysis, but we're just getting started on the effectiveness analysis. Our data collaborative purpose is to utilize data. Some of our members have pretty good AMI coverage, and it's pretty important for us to have that information so that we can identify, well, when a particular measure of a certain type was implemented, what was the immediate water savings or the savings within a given time frame. So anyway, we've got our work cut out for ourselves over the next 6 months or so to look at the effectiveness analysis. I could get into this, my consultant is actually online because I saw their name here. We're using EKI, Water and Environment, to help us with this. I am not the data nerd that I would need to be to actually dive into that detail, but thankfully there are people around who can help you as agencies like they're helping us here at BOSCA. So data and records, I have a half hour for this, so I'm not going to read every bullet, but I do want to say we have an old drought report, that 2017 one. I'm reviewing that in great detail, or I reviewed it, and our consultant is as well. I mentioned the urban plans. They have a wealth of information about what each of our member agencies would do during a drought. We want to actually take a look at what they say they're going to do during different stages and compare that to what they actually did. Governor executive orders, he issued, if my memory is right, 5 or 6, something like that. We're going to put each of those executive orders into the report so that it serves as a record as to what actions were taken, when, and why. We've got some information about one of the agencies that also serves the subset of BOSCA members that lie in Santa Clara County, and that's Valley Water. Santa Clara Valley Water District, but Valley Water for short. And we want to know when they took actions, because their actions impact at least those 8 agencies that we share in common. There's some information about various drought report measures and conservation programs, media campaigns that were run, and we're going to document what those were, when they were taking place, the costs that those measures were. And again, we've got a lot of member agencies, so there's information that we'll collect based on whatever member was implementing those. And then there was also regional measures that were taken. SFPUC took regional measures on our behalf. Also, the state took various regional measures to try to help encourage water conservation and water savings by our customers. A lot of other things that we're looking at. We've got with internal to BOSCA, we created what we call a water conservation database, and that's used by each of our members to record and log in information about water use by customer type, along with other things. And so that database serves as a tool for our use during the drought report preparation. And last but not least, we have a drought allocation plan that each of our member agencies has to adhere to. See if I can explain this well. Since SFPUC supplies are limited during times of drought, they require when an emergency declaration is made of a water shortage, that each of our member agencies is then given an allocation of supply. So their supply isn't limitless. There's supposed to be some sort of limit to how much they can take, which is a little bit less than what their normal allocation would be. And we're going to record when that allocation request was made. It's called the Tier 2 formula, and how our agencies behaved. Some of them behaved well, others weren't able to encourage their customers to conserve to the degree that was required. So because it was a voluntary cutback versus a mandatory one, there wasn't a financial penalty to our member agencies that weren't able to meet this shortage. But if the drought would have continued, if it would have lasted into the following 2 years, this year that we're in, there's a very good likelihood that a mandatory cutback would have been required. So this type of information we think is important to record and to analyze and to have in this report that we're preparing. So I put this slide up there just to give you an idea of what some of the graphics are that are going to be in the report once it's finalized. This is just one graphic, and again, I want to credit EKI to help us put this together. You can see there was just a lot of actions. It hasn't been that long ago that we got out of this most recent drought, but we're going to graphically show and have other graphs that show this. What happened when the orders were issued by the state? Of course, we've got DWR and the State Water Resources Control Board also that were engaged, so we're going to try to document what they did as part of these actions. San Francisco PUC, their commission, took different actions. And then also individually at each of our agencies, they either went into stage 1 or stage 2 of their drought allocation plan. So we're going to try to document, or we will document that. We found that it helps a lot to have some sort of visuals to go with whatever we list, because if you have a visual, you can kind of see, and hopefully this figure shows it. It helps you appreciate just how active the different regulatory bodies, as well as us as agencies, were to essentially try to promote water use efficiency by the residents of our agencies. So again, this will all go into the report. We had something similar in the last drought report we prepared, and we find it's very useful. It gives us a good reminder of what can happen as a drought unfolds, what different actions are required. And again, we only really needed to go into stage 2 of our water shortage contingency plans, but gosh help us if we had to go into stage 3 or 4 if the drought became more severe. A lot more actions likely would have taken place. So now I'm going to dive into the data a little bit. I like graphics. I know that the consortium and our friends along this other side of the table that most of you can't see, they're numbers guys. So we have data tables as well as this, but this is just the initial graphic. I said I was about halfway through with my work, maybe a third to a halfway through. And this graphic, it shows over time. So this is from basically April of 2021 through September of 2023, just how the different stages progress depending on which agency. Again, we have 26 agencies, so the bar graph goes up to not, there's one agency that is small, so it's not required to do these drought stages, but the rest have. Or it probably was Stanford, because Stanford's so unique, it doesn't do a drought stage. But if you can see, you know, as the drought started in 2021, a couple of agencies were at stage 0 of their water shortage contingency plans. But soon as we got into 2022, you can see almost everybody was either into stage 2 or the equivalent of stage 2. That was mandated, if you will, by the state. So it's not like agencies had a big choice in the matter, but it's good to document when that happened. And so again, we're putting that information in the report. The timing of when these stages were taken also indicated what type of drought or water conservation measure was put in place. And again, that timing information I think will be very helpful as we do this effectiveness analysis that's coming later on as we enter into the summer and when we do that work. We've also started recording with the data that we have what the water savings actually was. Again, this is from all 26 of our member agencies. We had a target that the SFPUC had asked for. They wanted us as a region, this was kind of during the height of the drought, to show that we had conserved, I want to say it was, you know, up to about 15% regionally. So that's not just us, but also in city SFPUC. Again, it was a voluntary cutback that they called for. And if you folks remember, the governor also was looking for similar type of cutbacks elsewhere in the state. The Bay Area was really pretty good if you compared our savings, quote unquote, between that of other places in the state. But yet we really didn't reach that full 15% over time. We reached about 8%. And you can kind of show, you can see the line on this bar graph that our water use was cut by 8% over that period of the drought. You know, unfortunately, there were some months, you can see the greatest savings that took place was essentially in the May, June of 2022 timeframe. But during the winter months, really depending on the weather that was taking place, 2020 was our base year. It was, I think that base year had sort of a fairly wet early start to it. When we were in 2022, 2023, it wasn't wet, and there was kind of some higher temperatures during those 2 months. So our customers as a whole were actually using a little bit more water during the drought during those months. So just some interesting data, stuff that I think we'll definitely have in the report, things that perhaps are of interest to the data nerds in the room and the collaborative as well. Bay Area specific, certainly weather specific too, had some issues. We didn't reach that 15% goal. Kind of worries me a bit if we have a real severe drought that requires mandatory cutbacks. Are we going to be able to reach that? Question that we'll probably be able to answer in the future, because I do think we're going to have some more severe droughts to deal with. I doubt if you're going to read everything on the screen, but one of the first things we did as we started the study, and as our consultant helped us with this, is we asked our member agencies, and this was a survey. We had a request for information as well as an electronic survey, where we wanted to get a full accounting of what different drought measures they took. And so it was a pretty extensive list of different type of measures an agency could implement. Everything from weekly watering requirements. Maybe you could only water once a week or twice a week on certain days. And if you can see this, there's also some other restrictions. Maybe there was, I'll try to read this a little bit better. You can see I probably should have zoomed it in a little bit better, but there's different types of measures that agencies took. There was also different types of publications that agencies generated to try to get water use to lower. So we collected all this from our member agencies. It was kind of we wanted to make it simple for them. So it was kind of just check the box type of thing. If they implemented it, check the box. If they didn't, leave it blank. And then we also had some fill in the blanks too, if there was some particular measure that was of use and of interest. So that makes its way into our drought report. Okay, there's a couple of interesting results that we wanted to talk about. The first thing was a question that we posed our agencies. Did your agency increase rebates or funding for any local conservation programs, excluding Bosque or Valley Water Offer programs as a result of the drought? So like that question was posed again to our member agencies individually, such as ACWD, and we generated a list of things. So essentially 40% of our agencies said, yes, we did something unique. It's not something that, was a program offered by my agency for all agencies to use. It was something that they uniquely did. And here's a list of them on this slide. Some of them purchased additional conservation materials. Some of them increased the rebates for lawn begone. Some of them offered kits or add-ons for water conservation. I'd say a bulk of them looked at increasing advertising and outreach. And some of the real unique things and kind of expensive things, agencies that could afford to, hired part-time staff to help with their conservation service needs. Not all of our agencies have the luxury of being able to just hire staff on demand. And it's not like temporary water conservation staff are just waiting out there to be hired. They're professionals, and so they are kind of, if you will, they're not easy to find. But some of our agencies, Menlo Park is one that increased staff. And actually here in the room, ACWD had some part-time staff that they hired for this. So again, I think all of this information is important to record because we may or may not suggest that in the future, there's some sort of budgetary consideration that our agencies give to have that ability to hire staff when they need. Or perhaps maybe Bosque, my agency that serves on behalf of all 26, maybe there'll be a need for us to have the ability to provide temporary staff support during a drought to help our member agencies. Again, if you get back and look at that prior slide, we were able to hit 8% water savings through the course of the drought, but our water supplier, SAPUC, wanted us to reach to 15. So we're all going to have to think about that. How can I get to whatever the target is of water use reduction? And the goal of our efficient or effectiveness analysis is going to be hopefully to determine what measures are most effective. Lawn begone, for example, is a great measure, but it's pretty expensive to for a homeowner and for an agency to suddenly have the big pot of money to take out grass and put in, drought tolerant landscaping. But some of the smaller type rebates are fairly effective. They're not expensive, and maybe they result in a lot of water savings. One of the other things that you think about during a drought is, did you have some water quality issues that were created by all these different measures that you had to put in place? We asked that of our agencies, and you can see that there was a number of them that did indicate that they did have some water quality problems. I won't get into all the issues, but they had to deal with, you really can't flush your lines as often when you're worried about wasting water. And so just the standard maintenance that an agency needs to do wasn't taking place. And because perhaps it's been delayed or not taking place, did that result in a water quality problem for your water agency? Other things, there's reservoirs and tanks. Sometimes, water tanks, if your water use is lower, maybe water is staying in tanks longer. I won't go into the issues, but that can cause a water quality problem as well. And so we want to document what those problems were. We didn't do that as part of our prior report, but we want to do that now. Is that a big concern that we need to be aware of in the future? And, I believe it will be. And now that information will be put in the report, and we'll try to dive a little bit more deep into it when we share that information with the rest of our member agencies and the public. So in the next steps, this is what I guess the collaborative I'm hopeful would be most interested in. And I wish I had a whole bunch of information to share, because then I think I'd be of more interest to you folks in the room that are the data nerds, but we're just getting started with it. So I just don't have the money. I'll tell you the truth. I don't have the money to have all 26 of our member agencies do this deep dive into the data that they've collected during the drought. And frankly, not all of them have the data. Not all of them have AMI in place. Some of them have a partial implementation of AMI. A good example right now, ACWD just fully implemented it, but they didn't have full implementation during this drought. I believe it was partial. And but a couple of other member agencies did. Redwood City is one of our member agencies, as well as Persimmon Hills. They're fully implemented with AMI. So I needed to pick a subset. 5 agencies is what I'm looking at. And I had to ask some questions about, are they somebody I want to put in this effectiveness study? And the questions are pretty simple. I mean, do they have data of some sort? Maybe it won't be AMI, but just data that actually I can use to look at the effectiveness of different drought measures. And are they willing to share that data? Let's face it, a lot of AMI data is held very tightly, and rightly so, because it has residents' names and specific information associated with it. So we need to be very cautious at BOSCA, and those agencies that we're going to seek to be partnering with us on this need to be very cautious about, is it okay for them to release the data, and what is going to be required for them to do so. Do they have different water use profiles? We're looking at that as well. So, some of our member agencies are primarily residential, and then there's other parts of our BOSCA service area that have a mix. They might have, when I say residential, maybe single family. Others have multifamily. Some have business industry components. So we want to have those 5 that we select to be different. I don't want to only include BOSCA member agencies that are maybe 90 or 95% single family residential. I want to have a bit different to look at, because I want to find out, did a daily watering ban really mean anything to somebody that really has got a very different mix of customer types? Do they implement different drought actions? So, as I pointed out on that earlier graphic, some agencies were in stage 2 of their water conservation or water shortage contingency plans. Their stage 2 probably looks different. Most likely it will look different than another of BOSCA member agencies. And I'd actually like to find some that have those differences so that I can evaluate that as part of effectiveness. When I say, do they have different water use profiles, I guess what I'd say is, aside from just the, residential versus industrial, I also want to look at demographics too. Are they wealthy? I mentioned that some parts of the BOSCA service area are wealthy, or are they poor, or are they middle class? Do they have large homes with small yards, or are they small homes with small yards? Are they estate type properties? I'll tell you the truth. BOSCA's service area includes 1 or 2 water districts or water agencies that serve what I call the uber wealthy. They're not homes, they're estates. And they're not yards, they're horse stables or other types of things. So it's just going to be really interesting. And when we look at these 5 agencies that we want to select, we want to have differences, because that's going to help us, we think, in looking at doing this effectiveness analysis. And geographically, BOSCA's kind of unique. We've got parts of our service area over on the peninsula. Even Half Moon Bay is one of our, well, it's actually Coastside County Water District that serves Half Moon Bay. Their weather is quite a bit different than ACWD's here. Even today, their weather is quite a bit different, because I'd probably be in a nice little sweater jacket if I was over there, versus today, where I really should be in a short sleeve shirt, I think, over here at ACWD. So, that's one of the nice things that I can do, though, as part of having BOSCA do this study, is I can pick an agency that's over here in Alameda, pick another one that's over in Santa Clara County, and pick one that's over in San Mateo, and maybe pick one that's in San Mateo and along the bay versus along the coast. So we want to look at that. So I think, at least from my perspective, this drought report, and most specifically this effective analysis, will benefit from the fact that BOSCA has a pretty diverse group of member agencies. So what am I going to do to use this data? Well, if I look at it, I want to look to see, what is the extent that our customers complied with the requests that were made. There was outdoor water restrictions. AMI data or other data should be able to tell me, you know, were those listened to? Were they followed? We didn't necessarily have a bunch of water police going around, but I know that I think in Santa Clara they did, in Santa Clara County. We want to look at and see whether it was effective, and we'll know the timing of when a different measure took place. We'll have data that shows, you know, hopefully on daily, if, you know, maybe more frequently than daily, clearly if it's AMI. We'll be able to tell, was there immediate lowering of water use when a particular water restriction was made. Total savings, how that compares across the different customer types. And we'll do some analysis on that. And also from this subset, we're gonna extend that to the degree that we can for the other agencies that weren't part of the survey. So I know, for example, I know that some of my member agencies are quite similar. Maybe they don't all have AMI, but they're quite similar. So I'll try to sort of bridge the gap between the 5 that I'm looking at and the 21 that are not included. So again, it's just getting started. Maybe 6 months from now, I'll have some really interesting information to share. But that's the plan for our drought report and the analysis that we're embarking upon. One thing that I wanted to mention, it's, you know, aside from this effectiveness analysis, and this is kind of one of my last slides, we're going to prepare a drought response tool. So it's kind of one of our last tasks. So this will be a tool that each of our member agencies will have access to, and it will be built on the findings that we come up with in terms of which measures are effective or how effective various measures were. And we believe that this tool, which will probably be Excel based, but this tool will serve to help them plan for the future. Maybe it'll help them when they're doing their next urban water management plan, and try to come up with, well, if we're in a stage 2 and I need to cut back the water use by X amount, let me play around with this tool and see if that actually, this combination of measures helps generate that type of water savings. But again, that tool will be prepared and again, made available to our member agencies. The drought report itself, though, that's going to be available to everybody, not just our member agencies. We always publish that stuff on our website. Probably there'll be some speaking at different conferences to talk about what's included and most specifically, probably the results of some of these effectiveness studies. The last but not least, I just wanted to say again, thank you for allowing me to come today. Might not have used all my 30 minutes, but I came pretty close. I'm always available to speak to you about not just this, but other BOSCA efforts. We'll have this work done towards the late part of the fall. And so I might have more to share after that point. Again, our consultant is doing a great job. Kind of stole a lot of their slides today. They do a pretty good job discussing the work as well. And happy to answer any questions. Well, go ahead. Mhm. Mhm.
Get like 15% reduction with the urban water use objectives. Would SFPUC probably change their approach, or would it also be like a number for every single?
Yeah, didn't go into this, but you know, since there might not be other questions, I'll spend some time. So there's this document that's a contract that each of our member agencies signed with the SFPUC. It's really the city and county of San Francisco that has a lot of rights.
It's called the water supply agreement. The water supply agreement really doesn't change much. We can make amendments to it, but the water supply agreement has a defined way that is used to determine how much water supply goes to the city of San Francisco and how much goes to its wholesale customers. So the city, in general, they use about 33% of all the water supply from the regional water system. And we, the wholesale customers, use about 67%. So they'll use that's called the tier 1 formula. And it says, well, during a drought, no matter how much supply I have available, tier 1 will tell me how much is made available to you, quote unquote, the wholesale customers. Then we, the wholesale customers, internally, we develop what we call a tier 2 plan, where we, the 26 of us, determine how much we're going to divvy up, how we divvy up that supply. And I won't go into how complicated it is, but it is a complicated formula. Agencies have argued about it over time. It takes a while to come up with a new formula, but we have a formula in place. San Francisco won't necessarily say, okay, ACWD, you have to cut back by 10%, and over in Santa Clara, city of Santa Clara, you have to cut back by 15%. But I will tell you that tier 2 formula does that exactly. It'll take whatever supply is available and determine what type of water supply reduction each agency needs to make. And it's based on a lot of factors. Health and safety needs go into the tier 2 formula. That's one of the components. It will look at things such as availability of alternative supplies. It has a lot of different factors that go into that formula. And so without going into more detail, I just say it's very specific in terms of what cutback each agency is going to get. But San Francisco doesn't make that determination. That tier 2 formula that our agencies have adopted is how it's made. Yeah.
So on, I think a couple slides back, you had said something, you guys were also going to be looking at regional marketing. Is that the marketing that Boston did, or you in conjunction with your agencies?
Yeah, I'd say it's a little bit of both. You know, the Bay Area did have a bit of a regional campaign, the drought campaign that was done. You know, ACWD, East Bay Mud, SFPUC, the water district. It wasn't necessarily as broad of a regional campaign as during the 2014 through 17 drought, though. And San Francisco PUC, though, they did have a regional campaign. I think they spent about $400,000 on it. They also paid to have, for example, they had a sponsorship of one of the Giants games for a while, where they had a lot of public flyers made out about water savings and advertisements that were made. So regional on a state level, regional on a local level, and by what I call some of the regional agencies, Valley Water and SFPUC. So.
Well, look at any of the media that was.
We're looking specifically at what media advertisements were made by the SFPUC that ran away. But beyond that, I don't think we're looking too much more at what the state does a great job on preparing. Save Our Water. I forget what the name of their campaign is, but some of our member agencies do rely on that because they are very good at the state level about providing that information for agencies to use for their own marketing needs. Yeah.
Yeah, thank you. And this sounds like it's going to be a really helpful document for everybody to evaluate what's worked and what hasn't. I was just wondering if there was any consideration for accountability on some of these effectiveness measures, like, you didn't say what you were going to do, what now?
Yeah, well, I talked about how at least we had some recommendations in 2017, or, findings, if you will. I want to see how many of those findings were implemented, and accountability might be too hard of a word, but if it would be nice to find out if somebody did a stage 2 drought. Did they actually implement everything that they said they did? And the timing as well. Did they delay the timing of certain things because they were harder to either pay for or maybe problematic in terms of what they thought? Elected officials like certain things and they don't like other things. And so some things are a little more difficult. hate to say accountability, but we are going to certainly say these measures were implemented, these measures weren't, and was it part of your stage 2 or not? So that definitely will be part of the plan. Any other questions? Yeah, go ahead.
So I look forward to seeing a drought response tool. Was there something like that released, after the last drought report, or this is a new thing that's gonna help inform the water shortage contingency planning?
Yeah, you know, it's a new thing for us. And I know there's different tools out there developed for, you know, like, for example, the water use efficiency efforts, there's various tools that have been developed. For this drought response tool, it'll be new to VOSCA, offered to all of our member agencies, hopefully tailored to the types of programs you folks have implemented or plan to implement. You know, until I build it, I hate to say, here's what it's gonna look like, because I need to see it. Probably all of you who work for agencies, you know, you read the proposals that come in the door. We had a bidding process for this work. I didn't even have that as a scope of work request, so to speak, but I did have the ability for the consultants to give me some optional tasks. This was one of them, and I thought, oh, that could be pretty cool. And I could afford it. And so I said, yeah, develop that tool. Anything else?
That was it.
No online questions. Well, they're all my consultants online. I hate to tell you. It's not happening.
Thank you so much, Tom. You wanna pass it on? Okay, thanks. Hello, everyone. I'm Negin Ashoori. I'm the Senior Water Resource Engineer for VOSCA. And today I'm going to talk a little about our water demand studies here at VOSCA.
The agenda today is to provide you a background on VOSCA, which, you know, Tom, thank you for providing that. And then we'll go through the history of VOSCA's water demand studies, specifically our 2022 demand study that we finished, the methodology as well as the results, and then what we have started just a few weeks ago, which is the 2025 water demand study, the methodology with that, and what we're trying to look for in the next year and a half with that study. Now, I won't talk about this again. Tom mentioned all of this, but I did want to emphasize that when we're looking at demand studies, it's important to know that because we have 26 different agencies, they're so unique. You know, we have some that only have a few thousand customers and others that have hundreds of thousands, some that are mostly residential and others that are mixed. And so we have to really look at it in a way that, you know, it's complex. And we work with consultants that are very much comfortable working with multiple agencies with different backgrounds. Now, here is a background on our previous demand studies. We have been doing this for a little more than 20 years. We started in 2002. Back then, it was very simple model where we looked at our residential number of households, how much water is used at each of those households, multiplying that by what we thought the population growth would be, adding that with, you know, our CII, the commercial, industrial, institutional, how much water is being used in that sector, and multiplying that by what we thought the job projections would be, and then subtracting out those conservation percentages. Now, we did that for 2004 and 2008, and then in 2015 is when we introduced this econometric model. So we use a statistical model looking at multiple variables beyond population, beyond, you know, job growth, looking at climate, looking at price. And we've done that for the last 3. We did it in 2020, but, you know, in 2020, we all know, you know, with COVID and with the drought, after that, there were a lot of changes. And so we actually, we usually do it every 5 years. We decided to do it just 2 years after to make sure that we're aligning it with our agency's 2020 urban water management plans, as well as seeing what those impacts from COVID really did to our agencies and their water demand.
I also wanted to highlight here that every time we've done a demand study, something has happened, you know? We had, with the drought or recession, 2008. So hopefully this time around, when we do 2025, no droughts, no recession, we'll be in the clear. But we also wanted to take that into consideration that like we need to be projecting that out as well, looking at how drought affects demand and how recession affects demand. And could we project that out in order for us to kind of plan out for that in the future? Now, this is really interesting because when we look at this, it's, in 2022 and 23, we see that there's a 32% less water that was used in the Bosque region compared to 1986 and 1987, despite this 34% increase in population. So we're seeing that people are using less water. And then we're also seeing in, these highlighted sections is where we see these drought years. And in these drought years, we see these drops in water demand, which we need to take into consideration here with the total water use, as well as the population that's we're seeing still continuing to go up, but it's kind of staying stagnant. So our water use per person is decreasing, and then our demand is staying pretty stagnant. So I'm going to talk about the 2022 water demand that we led. Our two main objectives, I mentioned it a little before, but the first is to really update our water demand projections that were developed in the 2020 water demand study to reflect that new data. So we had that new data and we wanted to see that effect of COVID and if it had any impact overall on our region. And what's interesting is for us, we, with our demand studies, we have specific demands for each of our agencies that we roll up together. So we're running 26 different water demands and then bringing that all up. So COVID could affect one agency more than the other. The second thing that we wanted to do, and this was new for us at that time, is we wanted to perform a sensitivity analysis to really better understand and quantify that uncertainty with our variables that we were looking at and how they impact water demand. So looking at not just one specific water demand model, but looking at a range of what that would look like so we can better plan for what demand would be in the future. Now, I know we all love data, and what we looked at specifically for the 2022 model is we plugged in our water conservation database, the production, consumption, and conservation activity. We actually have multitude number of conservation methods, and we ask each of those agencies, which of those programs are you currently signed up to do? And then what number of them are you thinking of doing in the future? Now, for the population and for the job projections, we looked at ABAG. That's the Association of Bay Area Governments. They have these projections of what that would look like. And we also have these top 200 CII users, seeing how much is the top usage, how much could be saved within that. And then we also took into consideration the data from each of our agencies' 2020 urban water management plans. And then with weather, we had the NOAA weather station specifically for each of the agencies. And then we had this other data workbooks. It's an Excel workbook that we sent to each of the agencies to fill out. We had it for 2020, and then we increased the number of years. We did it from 21 and 22 for that information. So we brought that all together into a regional model. Now, this is actually the results from all of our demand studies here. From, we have the historic demand from 1985 all the way to 2021 here with the blue line. And then you see here with those first 2 years that we did that demand study, 2004, 2008, those are the purple and dotted lines on the top. Those are a lot higher than what we projected out in the last few demand studies. And then the green one is the 2015 when we presented the econometric model with the statistical modeling. The 2020 and 2022, interestingly, they are similar. So even if we had that that extra information from 2021, from 2020, it didn't shift what our projections would be looking out. So with the impact of COVID and with the impact from the new information that we got from our urban water management plans in 2020, we didn't see that big of an impact. We saw a slight increase in 2022 for the projected demand, and that's after conservation. So it's a little above 250 MGDs. Currently, we are at about 205 MGDs. So we're saying from now until 2050, we would have that increase and as well as an increase in population. Now, what I had mentioned with the sensitivity analysis, which was the new thing that we had done in 2022, is we wanted to determine how to quantify that range, right? The range and uncertainty of water demand, and then to better understand the effects of key factors on water demand, looking at what specifically impacts demand more than others. And then we wanted to also serve it as a reference in tracking actual versus projected water demand in the future. So even like now, we can look at, you know, if we change those variables or the numbers and the variables, how does that match with what our demand is now? Are we on track, or do we need to make certain adjustments on our projections? And we had a lot of data. And we, you know, with our consultants, Medallis Water Management, we came down to 7 different ones. We had population and economic growth, housing density, climate change, water rates, conservation, and then the seasonal weather and economic cycles. So for population, we wanted to use data sets that we had actual data for. We didn't want to make up this information. So we had our historic data from what population growth would be, which is an increase of 0.84% historical increase every year. And then we also had this information from the Department of Finance, DOF, which is on the lower range. It's projecting out demand at a lower percentage compared to what we have historically seen. And then we also have this ABAG number, which is slightly above, you know, what we had historically seen. So it's at 1.1%. So we have this range specifically for each of these variables. And something that was new for this time for 2022 is we used housing density as well as a variable that we had not seen before. We were making assumptions. We're looking at how much single family to multifamily conversions there would be in each of our agencies. And so there are some that we know for sure they can't expand any more than they have already. And these are communications that we've had with each of those agencies to see how much can they grow out and how much can they convert from single family to multifamily. And then for climate change, we had, you know, the RCP either 4.5 or 8.5, that higher range of, you know, in the future it would be an increase of 2.2 degrees Fahrenheit, whereas that lower range of 1.6% Fahrenheit. And then we had these water rates, and we adjusted that for inflation, but we assumed, you know, it would either be a 0% increase, you know, adjusted to inflation, or an increase of 2.3%. And that's, you know, it doesn't seem like a lot on a yearly basis, but it's compounded. So even if it's a 2.3% every year, you know, that would be over a 50% increase in 2045. And that's, again, adjusted for inflation. And then for conservation, you know, we are assuming a higher or lower range. And then for the seasonal weather, you know, that this is applied to all the scenarios. We looked at what the drought has been and how it's impacted our agencies over the years, as well as the economic cycles. And then we use the average and apply that to all the scenarios to set a baseline for that demand. And what we see here, we had 5 different scenarios. I won't go through each of those scenarios, but the one on top, that blue line is really looking at, with high population, low conservation, increase in temperature, housing density decreasing, and lower price increase. What would that look like? What is our highest demand, with these likely scenarios? So it's not just looking at the highest number possible, but a likely range of what it would look like. And then we have this scenario E, which is the opposite of that. And then those triangles that I have there is the closest in line with what our demand model was. So you see that's in the middle. And then we have this difference, in 2045 of about 50 MGD. So, in our lowest range, we would assume that demand wouldn't change by much from where we are now. And then with that scenario A, we would assume there is going to be some increase in demand. Now, the key takeaways from that sensitivity analysis, again, we identified those 7 variables that have a potential to impact water demand. The population was actually shown to have the largest impact on water demand. We also did a run where we kept every other variables consistent, the same, and then population, we shifted it around, and we looked at that for each of those variables, and we saw that population had the biggest impact on our water demand, which is kind of most of the studies that we've seen have shown that. And then the resulting demand from the range of scenarios varied by up to 50 MGD in 2045. And then we're going to use this as a reference. Again, what I was saying is just tracking if we're on track with the projected water demands, and will help us with planning on our future decisions. Now on to the fun stuff of what we're doing now. We started this in just a few weeks ago, July 1st. And the reason why we do this so often, every 5 years or so, is because we give this information to our agencies in order for them to fill out their urban water management plans. Again, these are each individual models that we give out, 26 of them. But we also have, and what we're leading is BOSCA's long-term reliable water supply strategy. This is looking at not only what our demands are, but what our supplies might be in the future, and where we need to really put in that effort in filling that gap if there's anything. And what we've been hearing with that is also how to pay for it, right? With water affordability and being able to provide grants for that. But we also need to know what that difference is, what that demand in the future would be, and how we would fill that gap. And then this study would also help in the calculation of member agencies' annual urban water management, or the objectives, looking at indoor versus outdoor water use. And then looking at conservation again. We haven't looked at that for a few years. So our 2022 demand study, we didn't specifically change any of those conservation programs that we had done in 2020. So we are going to revisit that again. We're going to go to those agencies and say, which programs are you interested in now? Are you participating in? And then which ones are you going to be participating in the future? And we're hoping to make a lot of changes with that portion of it. Now, the method behind this is, again, we're still going to use that econometric model, but we're taking out that conservation side of it. So for the econometric, it really provides the ability to quantitatively evaluate that variability. And we're going to use that again for these variables. So with seasonal variability, with weather, price, that general economic conditions. We're going to look at COVID again in more depth with that, with the response and recovery is, and then that passive conservation as well. But with active conservation, we're going to use an end-use model. And the end-use model would be able to track what specifically our agencies are doing with conservation and how that's being used, and plugging those two together to forecast scenarios. So this is all the data that we're currently collecting. We have not sent out the workbook yet. We are finalizing that at the moment. But we're looking at, again, billing data by billing class or campus, user group, again, we have Stanford University. I'll show you in the next slide, but that's a unique one that we have to take into consideration. We're looking at the number of accounts billed by billing period, water rates, looking at those water structures and the water use data, as well as planning data and any relevant, sometimes that qualitative information is something that we need to use to be able to have a really good quantitative model. So having that communication with each of the agencies to understand, local housing and employment and any changes that might be coming up that we're not aware of. And then service area boundaries, we're not just looking, some of our agencies get some of their water from SFPUC. And so we use that GIS data to have those service area maps out to better understand the population and give us better numbers on that. And then a description of that active water conservation programs that I had mentioned. And then the timing and severity of water supply shortage restrictions, again, tying that back to tier 2 that Tom had mentioned. Now, I know Stanford University is unique. We can't just say that it's like any other water agencies. Okay, they have, that many number of population and this is how much they're using. No, their water usage is so unique. And, we have a lot of usage during the day, a lot less, at night. We have dorms, so there's a lot more usage, in 9 months. And then in the summer, there's actually less. So it's diving deep into that pattern, right? Where are they using the water? Maybe we can use it looking at historical estimates of population and beds, and maybe square footage by water user group would be helpful, really looking at where the water is being used, looking at the type of facility, building, that age of the building, to really tie into that conservation of how much water loss there is. So there's going to be a lot more communication with Stanford to get this information. Again, it's going to be a little qualitative as well as quantitative, but we don't have that, the number of accounts billed by billing period, it's mixed, we can understand, there's 700 people that live within that, campus, but to be able to have that fluctuation of water usage in the campus throughout the year, we just need to have more of that communication with Stanford on that. Now, I won't go into depth with this, but this is the overall modeling process. Again, we plug in that data with the water demand variability and trends and looking at that. And then we do that econometric model, right? Development to look at these baseline projection scenarios. That's without the conservation. That's without active conservation. So we're not talking about the passive, plumbing codes that we would put within that demand model. And then we would have this output. And then with that, this is new for us. The Alliance for Water Efficiency, they have this conservation tool. We haven't used it before at Bosca. We use the DSS model, decision support system before. So this is a new model where we would plug in those conservation programs and specifically look at the cost benefit from each of them and what that would be. And that's, again, communication with our agencies. We would be providing them with those workbooks to see what type of conservation programs they would have. And then together with those baseline projection scenarios that we had, we would have another projection scenario with the active programs. So adding that on to the Alliance tool that we would be using. And then we're also going to continue with that sensitivity analysis. We really liked having that range instead of just having that specific demand number, looking at that range. But going beyond that, we're also going to be showing, varying projections for each of those demand variables too, and showing, what specifically here, I don't know if you could see it, but what it would be for residential housing units. If we can have an increase or decrease of that, what would that do to demand? And then again, looking in more depth about the impact of each of those variables on demand in the future. We have previously used stakeholder engagement with that. We had nonprofits and other water agencies that came together to really develop those scenarios, and we will continue that. You know, we're using a new consultant, Hazen and Sawyer, but we're going to have the same kind of method of having that stakeholder engagement to get their input on what those scenarios should look like, and if there's other variables we should be looking into plugging into that model. And then something else that's different and new with our model is we were going to be simulating the impact of future drought events. You know, it's hard for us to do this. You know, we're looking at what drought would specifically be, like historically looking at it, what that would be, and then what we think it might be. And then we'll have probably a scenario planning specifically on the drought range. And then for the rebound, it's similar. We would look at historically how fast we rebounded and how that has impacted the water demand. But then that might change with demand hardening. There might just be a ceiling of how much can specifically be conserved. So we're going to look at some other studies. We're going to look at some other analyses to be able to plug in some of that. So have a range of historically how, the drought rebound, what that looked like, and then what the potential might be in the future. So again, that's not going to be a single number on what that would look like, but again, it will be a range. But I would love any, input any of you have, if you have other studies that have looked at that. This is, again, we have just recently started this, but we want to develop that kind of like envelope of future demands and really accounting for that potential impact of a future drought and being able to prepare for it as much as possible. So I think that was it for my presentation. I really thank you all for, having us here. The 2025 demand study, it's anticipated to be completed in the fall of 2025. We're hoping to have really great results that we can be presenting out. It will be made public. So thank you again. And if you have any questions, if you have any documents you think we should be looking at, please email me or call us. Yeah, thank you.
Thank you so much. I don't see any questions in the chat or the Q&A, but if anybody has them, please, you can raise your hand, you can put it in the Q&A. I had a question. Do you guys I'm not really familiar with this area, but did you have any ag areas that became multifamily or residential or CII in your region, or is it always mostly just single family mesh?
Our region has changed. Not necessarily the last 20 years, but San Mateo and Santa Clara counties used to be years and years ago. It used to be ag, like back in the 1900s through 1940s and 50s. Produce and oranges and all sorts of things. More recently, it used to be what I call your typical Silicon Valley. A lot of manufacturing, high tech, silicon chips and whatnot. Now it's changing again. These big, the Facebook and the Google type corporations, huge corporation campuses. In the future, we're going to see this big push for multifamily housing. Along transportation corridors and whatnot. So I'd say for the most part on the peninsula side, it's these large corporate campuses. There's some big biotech as well, but mostly residential. And over here, I'd say where I am here in Alameda County, there is more what I would call your standard, what you would think of as CII type customer bases. There's a mix of some in the Valley Water Service area, but generally speaking, we haven't seen ag here. The only member agency that has what I would, I hate to characterize it as ag, but over in Happy Bay, the Coastside County Water District, they used to have, flower growing and different things there. That's changed somewhat, but that's the only WASPA member agency that I'm aware of that has even a minor ag component right now.
Yeah, most of that shift is from single family to multifamily, or we're seeing the shifts with CII.
Yeah.
But yeah, I haven't seen the ag in the last 20 years.
Awesome.
I saw that you were, you were showing sort of the multiple uses for this sort of, these demand projections. One of them being for agencies to plan for the urban water use objective. But I'd be curious, like, are you factoring into account at all a sort of reverse effect of like the urban water use objective regulations on demand, and how are you incorporating about all that?
Definitely. And we actually use those, especially with the indoor versus outdoor water use, we use those numbers during the 2022 demands, just to project that out for water conservation. A lot of our agencies are already complying with those numbers. There are just a few that aren't. And then we took that into consideration with, decreasing that number in the future.
Okay, thanks.
But yeah, it is both ways.
Yeah.
We looked into it all, trying to decouple the demand from population, just based on like the historic record where the population is pretty linearly up, where the demand was trailing down. You been able to suss out what are maybe other major driving factors for that?
That our consultants looked at that. They haven't done it this time around. I think it was like the 2021 where we tried to look at that without it.
Yeah, I mean, I think for better or worse, we found that population was the biggest driver in what our demand estimate is going to be. And I don't have the details on the decoupling of it, but I know that was the conclusion that was reached. We're just starting this study, so we'll find out. The naysayers about demand studies, and there are plenty of naysayers, and I'm not trying to belittle them. They say that water agencies overestimate water demand in general in California, that we as water planners, we want to make sure that we have enough water supply to meet whatever the future growth might be of our region. Yet, one could argue that we overestimate demand, and because of it, we build more water supply projects, or we build more drought projects, and we use those demand estimates to justify those investments. So it is something that we decided in 2022 to let's just do a sensitivity analysis. What if population isn't going to grow the way that ABAG predicted? What if it grows more conservatively? And the Department of Finance has a much more conservative way of estimating population growth. So when we combine these different what ifs and create a sensitivity run or scenario, we wanted to make sure that that was one of them that we included. There's other things beyond population. Price sensitivity is something that, again, I hate to use the word naysayers, but I'm going to say it again. One of the naysayers say, if the cost of water goes up because you're building all these alternative water supply projects or whatever, people aren't going to buy water. They're going to conserve more or reduce their water use, and it's just going to then result in lower demand. So you need to make sure you include some in your scenario planning, some way to show what if price of water results in a lower use of water. So all those things we knew we needed to include in the scenario analysis. But yet, on the other hand, we're charged with developing a base demand estimate. So I can do all the scenario planning in the world, but I still, ACWD is one of our member agencies. You still want to know, what do you predict my demand is going to be in the future? And so I give you a prediction. It's a number. And then I have this scenario planning that results in kind of a nice, sort of degree of like, well, if we don't grow in the future, then I have this demand number that's lower. So 4 or 5 years now, if I look at population and I say, hey, I really didn't grow in the Bay Area, I'll have this study that I could refer back to and say, how close did my demand in 2030
by the city in 2030. How close did it align with one of my scenarios that included a flat population growth? So hopefully that scenario planning is going to be helpful for us to at least make sure that we have a demand study that provides for that level of uncertainty or considerations of uncertainty. Hopefully that makes sense. That can be quite.
Information does, you know, and sometimes like overshadows other, you know, variables in it. And I know that we have looked at each one individually just to make sure they're statistically significant and they have an impact on demand. But yeah, maybe decoupling it in a way with running all the other variables together.
Yeah, and I ask because we run into the same challenge of trying to decouple our projections from the population when historically the population doesn't seem like the major driver. There's these other factors that come swinging in, but it's such a statistical challenge.
Yeah.
Exactly.
Any other questions?
I wanted to see more online questions.
Thank you so much. I just have a couple of quick announcements. Thank you.
I invite you all to our California Water Data Summits coming up August 15th and 16th at the University of San Diego. You can get to our registration page by visiting the CaDC.org. We have an online community I talked about a little bit, but this is where you can potentially get different kinds of research papers and abstracts and things like that. So please, you know, we invite all of you to go check out the free resources that are there. Talked about Wavelet already. You can reach out to me at any time if you have questions about the CaDC. But thank you so much. We will have this recording up tomorrow and we appreciate your time. Hope to see you at another webinar or the summit very soon. Thank you so much.